Okay, well, let's solve this part 2 graphically. So I've brought up Desmos. I'm signed in, got my name there. This really is me. There's my picture. Um, okay, so we need to define a couple things. So, for instance, we need a T0. Now, I'm going to do T and then 0, and it automatically puts it as a subscript. Now, if I say equals, that even worked nicely. It just, I haven't had to do anything too special. And I'm going to say T0 equals 0. Now, this is adding what we call a slider to give different values. I'm not going to tell it anything different than its default. I'm just going to hit enter, and it defaults to be between -10 and 10. Now I need a P0, so P, I'll use lowercase P0, and that equals 1. Now in this case, I don't want the default -10 to 10. I'd probably like just 0 to 2, and so I can put those in. Now, if you didn't like that, you can always change these numbers simply by clicking down there, and you see it goes back to that. And you can add a step size, but I don't want to. I just want it to kind of flow freely between those. So I have my P0. Now I also need my delta T, right? Now in this case, there's no Greek letter delta. I guess I could use like a D sub T or something like that. This is a bit cumbersome for us, but just to kind of get the point across, I'm going to use an uppercase D for uppercase delta. Then I'm going to do an underscore, which puts me into the subscript region, and say delta T, no spaces, so it looks kind of like deltat, but it's delta T. Now, see, if I hit equals, it's down in the bottom, so I have to hit my up arrow or something like that to get back up to where I can put an equal sign, and we'll make that 0.1, and again, this for my step size, well, no smaller than 0, and maybe no bigger than 0.5. We'll come back to that at some point. And so there I have all my initial constants put in, and so now I'm going to make my first straight line. And my first straight line I'm going to call P1 of X. Now, you would like it to be of T, but this is one of these things. I could use a T, but it tends to confuse Desmos. If I'm just trying to do a graph on here, almost always I will use an X, even if I would prefer some other letter. So now this equals, and remember our point slope form, we need our P0. Okay, so that was the initial point, P0, and then plus our P0, because that's also our slope, so P0 times X minus T0. Okay, so I have that, and notice how it's going off the edge over here. What you can do is you can kind of reach in here, grab this, and pull it over. So I'm going to pull it over quite a ways, so we have quite a bit of room to put things in. Okay, so I have that. There's a straight line. Now I can update. Well, I need my next T value, so I'll put in my T1, and that equals my T0 plus my delta T. Now again, this part's cumbersome. Delta t, like that. And notice down here it just says 0.1. Now I'm going to move my funny face up here. And so we have our delta t, and now I am ready to, so I've got my first straight line. I've gone here to 0.1. Now this is another thing, probably I want to manipulate the graph a little bit, and since I'm only going to 1, I'd probably like to zoom way out here like this. Now I can okay, so I can do that. Now I might have to mess with the y-axis a bit because I'm already near the top of it, but I'll wait once here to do that. So now I need my P2. So my next line made from the end of P1, so I want to go here. Alright, I can click on there and I can see that that's at 0.1, 1.1, but I don't want to make it that way. Instead, what I'll do so I can update it a little more automatically is, how did I get this point here? 0.1, if I can get to it there. How did I get there? Well, I'm looking at the function there, P1 of x, and I'm asking what's P1 of 0.1. Oh, so that's what I'm going to use. So I'm going to use P1 at 0.1. Whoops, not 0.1. Actually, I want to just say T1 because that's 0.1. So I have that plus my P1 at T1. So there's my slope times x minus my T1 because that's my point. And I do that, and you see I've got that entered. Now's the time that probably let's the y-axis, let's have it go to maybe 3. Okay, and so I do that. Now you could adjust your other pieces as well if you wanted, but this does it. Now so now I want to kind of do this same thing again. And what's nice is I can copy this. Now notice when I try to do it this way, it doesn't work. So I actually do have to use the Control and C pieces to do a copy, but then once I do, I can click down here, Control V, and paste. And well, this needs to be T2 and that needs to be T1. So I have to change those, but it was that quick. I didn't have to type that darn delta T thing again. And similarly, I can copy this whole thing. So Control and C, come down here and paste it, Control V, and I can update this with, I can make that a P3, and all these are 2s. So I have to do some editing, but I can quickly do that. Now, I can't see a darn thing here, right? This is basically impossible to see, and so I need to do something else to help this out. I'm only interested in this function up here between 0 and 0.1. I'm only interested in this one between 0.1 and 0.2, and this one between 0.2 and 0.3. So it would be nice if I could tell Desmos to do that, and actually I can quite easily. So if I ahead of my function, I can give its domain. See, so we are using these words from the the chapter, so domain. And what I want is that domain to go from 0 less than or equal, and it automatically makes a nice less than or equal to sign when I do that. X is less than or equal, and I'll use my, notice I forgot to do the underscore, so it's writing delta, see, up top, and it not going to know what that means, so there's my underscore, ELTAT, like that, and then come back up, and then I need a colon, and that should do it, except for one other thing. I do need to put curly braces around it, and as soon as I do, there you go, and notice it only goes in that piece. So if I turn these off just by clicking on the color, you see I just got that part. And so I'm going to do that same thing down with these, same sort of thing. So I'm going to go up here and highlight that much, do my Control C, come down here, do my opening curly brace, do my Control V paste, and then be careful. Notice when I'm here, I've got a little hand showing. If I click right now, it'll actually make this cell disappear because it thinks I'm on the X. So one thing I can do again is just make this a little longer, and notice it put the other curly brace in there for me when I put this one in. Now I need, so I'm going to do a Control C, I need to start at delta T and go to 2 delta T. And once again, it's kind of wide, so I'll just come over here a little more, about there. And so now I fixed that one. Now I'm going to highlight this, do my Control C for a copy. Again, come in here, do my opening curly brace, paste that in with Control V. Now here I need 2 delta T, and that one 3, and they're beautiful. Okay, I'm getting each piece as I go. So now I have a bunch more of these to do, and I could do it sort of one at a time, right? I can copy this one, do my Control C, I can paste it here, Control V, and then update the numbers. Notice this all of a sudden has an error. The reason it has an error is it's using this T2, and I've defined T2 twice. Even though it's the same thing, Desmos knows that's not a good idea to define the same thing twice, so it says it doesn't know what to do here anymore. As soon as we fix up the T2 into a T3 and the T1 into a T2, we'll be all set. Now, so I can do that, but another way to go is, because I can always cut and paste in the middle of things and so forth, actually I'm just going to put a bunch of these in here. Okay, so here I got to T2. I need to get to I guess T9, because T2 allowed me to do P3, and I need to get to my 10th piece. So this is going, that's T2, this one's going to be T3, T4, T5, T6, T7, T8, and T9. So there's T9, and it was from T8, and so it just graphs something there because the best it can tell, it's trying to do some sort of function because it doesn't know what T8 is. This one's 7 and 8. Using my skills of counting backwards, 7 and 6, 6 and 5, 5 and 4. I know this gets excruciating with how slow I am at this, but hey, we'll get over it. 3, and then finally 3 and 2. Okay, and all those lines disappear because now it knows what these are, right? See, it takes me up 0.3, 0.4, 0.5, and all that. Now I can do the same thing here with this. I'm going to highlight that whole thing, do my Control C. Now I'm just going to come down here and hit enter like that, and that opens it up there. And there's my P4. Click there, hit enter. P5. Click, hit enter. Control V for P6. Hit enter, Control V. Enter, Control V. Enter, Control V. And enter, Control V. And once again, you know, I could either start at the top up here. So P3 was the correct thing, and now I make that P4. Now I got a lot of changes to do in here. So you know, there's P4, that becomes a 3, that becomes a 4, that becomes a 3 and a 3 and a 3 and a 3 and a 3. Now I was looking for you know, better ways to do this, and let's see, I think I got that. P3, it's not doesn't seem to be happy. Let me hit enter and just see. No, it's not happy. I can get rid of this that I just added. So I need to figure out, you know, okay, what did I mess up? Here I have the T3, P4. Oh, it may not be happy. Now that I think about it, it may not be happy because I've got various things defined down here more than once, right? P3, there's a P3, there's a P3, and so forth. So that's a 5. So I just go through and do what I know I need to do. 4, 5, 4, 4, 4. So like I say, this is excruciating, but you can watch me do it, and well, hopefully by the end of this it will all work. If not, well, we'll have to figure out what went wrong. Okay, so this is 5 and 6 and 5 and a 5. A lot of editing, and again, you could always sort of fast forward through this to see where I get, but I'm not going to stop it. I'm going to, you know, show you that I have to go through the same tedious stuff you do. You know, it's no different. I am, you know, at the slave of technology just like anybody else. And sometimes you just have to go through and take the time to do all these things. But I'm getting there. So there's 8, 7, and 8, 7, 7, 7, 7, 7, 9. I'm starting to see the light at the end of the tunnel. 8, 9, whoops, I said 9, typed an 8. Let's see, 8, 8, 8, 8, 8, and finally 10. And see, everything all of a sudden appears because nothing's defined more than once. And so now I have 9, 10, and do my 9, 9, 9, 9, and I need to make this just a little bit wider, and 9, and there we go. So there is the picture of my curve. Okay, so I put all this in. I've got this nice picture, and you know, I could do a screenshot of this sort of thing, right? You know, again, you know, how would I do that? You know, I do a control plus a print screen, and so you see it did that again, and I could go into my document as I've shown in other videos, paste this and crop it as needed, and I have this nice picture. Okay, now you can add some labels in Desmos and all that. It actually is a little bit nastier to do it than one would like, and at this point I'm not too worried about it. We have our stuff here. Now if I'd like to try to fit more of this on this page before I do a print screen, I could always do a control minus to you know, reduce everything in size. See up here it says now everything's at 50%, and I got all the way down here to 10. Now, you know, if I show the stuff up at the top, I still can't show it all. You know, this is all really small, so you know, this would show all the commands, or most of the commands, but it's not very pretty, so I wouldn't suggest that. I'll go back up here to you know, maybe 80 or 90%. You know, this is 80%, and it shows a few more of the commands, that kind of thing. But again, you know, you're just not going to be able to show them all in one picture with this many. Whoops, make it bigger here. Okay, there I'm back at 100%, and there you have it. But there I've been able to do it. Now I'll give the answer away. The actual answer to this as a differential equation is e to the x, and so if I just type e to the x here, it plots that. And so notice we did pretty well, but also I'd like to point out what this delta t does. One of the things it does. Now if I make delta t bigger, okay, look at this gap here or this gap here. Okay, so here we're at 1, so that gap right now is about 0.1. If I make delta t bigger, okay, my solution, my numerical solution, is going to go out here farther, but look what's happening here at 1. That gap is getting bigger. As I make delta t bigger, that gap gets bigger and bigger and bigger. Now if I come back down here to 0.1, and you know, I can't quite get it to 0.1, so just make it 0.1, hit enter. There it's back at 0.1. So as I shrink it smaller, this endpoint's going to come this way. So let's look at the 0.5, and notice it's kind of hard to see, but there is a little gap in between the two curves. And as I make this smaller and I come down to here, okay, if I make this 0.5, 0.05 that is, then looking here, that gap has pretty much disappeared. I can see the difference between the two curves, but the gap has gotten smaller. And so that's what your delta t will do. And so it's a matter, you know, how much how much do you want to be off in your approximation? Well, to try to make that approximation better and better, you make delta t smaller and smaller. Now, if you don't know what the real answer is, it's kind of hard to tell how far you're off. But actually, there are numerical methods that use calculus and the understanding of functions to get an idea of how big that error might be. Okay, so there we've solved it graphically with all these little straight lines, and we get in this nice picture, and we could even go up here and click on this to see what we get as an answer at 1, and we get 2.5937. So since we know the answer is come back down here to 1. We know the answer is more like 2.7128 or 2.713, and we're off a little bit, but not too bad. So if we wanted to be closer, we would make delta t smaller and just make more of these little straight line functions. So there we have it.